Assalamualaikum and good morning to everyone. My name is Aiman Bali and today I will present my review paper entitled A Review of Virtual Reality of for Practical Skills Training in Engineering Education. This paper reviews how virtual reality or VR is being used to improve practical engineering education, compares different VR techniques, identifies their advantages and limitations, and discuss future research direction. So, in practical skills training plays a fundamental role in engineering education by enabling students to apply theoretical knowledge in real situations. However, traditional practical training often faces challenges such as high operational costs, limited laboratory facilities, safety risks, and restricted access to equipment. To overcome this limitation, virtual reality or VR has emerged as an innovative learning technology that provides immersive, interactive, and safe virtual environment. These are five challenges of traditional practical training. First, expensive laboratory equipment and maintenance. Second, the limited access to engineering laboratories. And the third one, safety concerns during hazardous experiments. And next, insufficient opportunities for repeated practice. And the last one, learning disruption during events such as COVID-19. There are five objectives in this review paper. The first one is to review the application of virtual reality in engineering education. The second one is to compare different VR techniques used for practical skills training. The third one to identify the strengths and limitations of each VR approach. The fourth one is to determine the most suitable VR technology for engineering education. And the last one to discuss a future research direction in VR-based learning. So, what is virtual reality? Virtual reality is a computer generated environment that allows users to interact with virtual objects in a realistic way. Unlike traditional learning, VR creates an immersive learning experience through visualization, interaction, and simulation. The benefits of virtual reality is it is a realistic learning experience, such as we in the real world. The second one is it has interactive learning. It has it is better for student engagement and can also improve knowledge retention. So there are three types of virtual reality. The first one is non-immersive VR, where it uses desktop computers and standard input devices. It also has a low cost and easy to access. Non-immersive VR also has a limited realism. The second one is semi-immersive VR. It uses projection system on multiple screens to have a better visualization than desktop VR. It also has a moderate immersion. And the last one is a fully immersive VR. It uses head-mounted display, which is HMDS, which provide the highest level of immersion and also supports natural interaction with virtual environments. So these are the five existing VR techniques. The first one is desktop VR, which the main application is CAD, which is the computer aided design and engineering simulation. The second one is mobile VR, which the main application is virtual laboratory learning. The third one is a KVR, which is the industrial simulation. And the fourth one, which is the head mounted display, which is HMD VR. The main application is for welding, assembly, and equipment training. And the last one is collaborative VR, which is a team-based engineering training. So here are the list of the comparison of the VR techniques. So here we can see that HMD VR has the highest immersion level, and for the cost, the desktop and mobile has the lowest cost, and the accessibility is the desktop and mobile VR has the highest accessibility, and the learning effectiveness, the KIF and the HMD and also the collaborative have the highest learning effectiveness. So out of the five techniques, I choose HMD VR as the best choice. So why HMD VR is the best choices to apply in this VR in practical engineering education? Because these are the a few advantages why I choose HMD VR as the best choice. First, it has the highest level of immersion. It has a realistic 3D interaction. It has a safe environment for practical training and also portable and increasingly affordable. It also suitable for the engineering education such as welding, machine operation, equipment assembly, and also safety training. For example, you can use the MetaQuest, HTC Vive, and also Valve Index. So there are a few benefits of VR in engineering education and also a limitation. So the first, I'm going to share about the benefits. So the first benefit is to improve practical and technical skills, provide a safe learning environment, and also to increase student engagement and motivation, to reduce long-term training costs, and also supports remote and flexible learning. So the limitation of VR also, it has a high implementation cost. It also can cause a motion sickness and user discomfort. It also has an expensive hardware requirement. It also included as a limited haptic touch feedback and also no standardized assessment method. Future research should focus on making VR smarter and more realistic. One important direction is integrating artificial intelligence to provide personalized learning and intelligent feedback. Researchers should also develop adaptive learning systems that adjust training based on student performance. Another area is haptic technology, which can provide realistic touch sensation. Digital twin technology can also improve realism by creating virtual copies of real industrial systems. Finally, cloud VR, 5G networks, and learning analytics improve accessibility, collaboration, and performance evaluation. So, to conclude this presentation, virtual reality has become a promising technology for practical skills training in engineering education. Different VR techniques provide different levels of immersion, accessibility, and learning effectiveness. Among all techniques, HMD VR is considered the best option because it provides high immersion, realistic interaction, portability, and reasonable cost. Although challenges such as implementation costs, motion sickness, hardware limitation, and lack of haptic feedback still exist, future technologies like AI, digital twins, cloud VR, and haptic system are expected to overcome these issues. Overall, VR has a great potential to bridge the gap between theoretical learning and practical engineering skills. That's all for my presentation today. Thank you for your attention and hope you enjoy watching this video.